Welcome back. After checking what the monolith approach was, we try to take it to the next level, and then I gave this level the name encapsulation. We will see quite soon why. When you learn about object-oriented programming in the textbook, probably you will see three main characteristics of object-oriented programming. The first one is the encapsulation, and the two others are inheritance and polymorphism. So in this level, probably the easiest idea to grasp is encapsulation. We want to somehow not put all the functionality into one class, but we want to put into different classes. So in this stage, we expect that it is now understood. So what is encapsulation? And then let's see how we can use it to improve our design. Suddenly, our design is now broken up into separate classes. For example, here we can see there is the image sensor, there is the algorithm, then we have the UI, the take photo panel, and then we have, let's say, a main class that is responsible to fire up the whole application. Also an interesting approach here that you see here these arrows, or actually these lines between the boxes, and then there are some diamonds. This is the aggregation, and then it means the class which has the diamond is physically containing the other box. In some programming languages like C++, this is really possible. Then you can take a class, you can put another class inside there, and then the size of the class, the owning class, is increased by the size of the other class, more or less, let's say. And then there are some other programming languages. Usually, those are garbage collected languages like C Sharp, Java, or even Python, where you cannot really physically put one class into the other one, but you can put a reference to another class, and this is what you can store. Here, we don't want to go into this detail. We just consider them as aggregation. Now let's see what those classes contain. Let's start from the bottom. Our image sensor class contains the take photo, take video, and zoom functions. The take photo function could be familiar from the previous step. All the hardware communication is put into here. We take the resolution and then we return the image. This is all what we need for our application. But let's suppose that our camera hardware also supports video. So we can do it quite similarly. We, let's say, set the bitrate, and then inside the implementation we have some hardware management, and then finally we will get the video back. And then this camera sensor also has a zoom factor, very same functionality, very same concept. We call it with the zoom factor, and then we talk to the hardware, and finally the zooming of the lens will be set as we want. Let's see how does it look like with the image algorithm. So we have here this take photo function where we talk to the sensor in the first line, and then we execute the beautification algorithm. And now this is the really interesting part, that in the last line we have the image sensor. So basically it means that the image enhancement algorithm really contains the sensor. It means that when the image enhancement algorithm is created, then it is creating the image sensor with it. And then because it is inside, then it is able to use and call the sensor functionality. Of course, here the take photo functionality. We see here also some problem, because we have here the image sensor as a concrete class, a concrete sensor type. And then if we have another sensor type, then maybe we will again just call the take photo function, but that is another class, and then we are losing here some flexibility, and then we can't really easily replace it with the sensor B without recompiling the code, of course. And then let's have a look. This is the photo panel. We have these two familiar members, so the button and the combo box. But now we have the image enhancement algorithm inside the take photo panel. And then the take photo panel is calling the image algorithm, which in turn calls the image sensor. And then finally we will get back the image, and then we save the image. And then finally we need the main class that is starting up the whole application. This is instantiating the take photo panel, that is instantiating the image enhancement algorithm, and then that instantiates the image sensor. So basically the system is building up itself when we are instantiating the take photo panel. And then here in the constructor, we are just kickstart the whole application by showing the panel. Again, if we look at the deployment, this is one possibility here. If we want to, because now we have separate classes, maybe we can decide here that if we have different classes, then we want to also have this kind of uh, this kind of uh, split in the library level. You can see we have the camera GUI library where we put the take panel, take photo panel. This is basically the presentation library. And then we have the image processing library where we have the algorithm. And then we have a camera sensor library where we place the camera itself. You can see that there is a dependency chain here on the bottom of the chain. The camera sensor library, probably we have there the easiest case because it doesn't have any dependencies, so this is quite easily reusable. But imagine that we have the image processing library. This is our core value, and then this core value depends on a specific sensor. So it means that it will be quite hard to use the image processing library, the algorithm inside, without a hardware. So you can run it if the hardware is present, and then we will see why it is not so good. So let's see what is positive about this approach. This encapsulation helps to separate concerns. So we don't have any more a very big block that is really hard to understand, but we broke it up to classes. And now finally we have some components. But we see that these classes are split up, but they are not independent from each other. So the higher we are in the hierarchy, so the closer we are in the to the main function, the less flexibility we have, because more and more part of the system is hard coded and rigid. We have seen that the packages and libraries, they cannot be composed freely. It is really hard to exchange them because the components are fitted too tightly, and then this is also reflected in the deployment on the library. So the rigidity in the class hierarchy also brings in rigidity in the library deployment. Product variants are still really hard to do. So just imagine if you have the panel, and then if you want to make another panel, then you will have to create a new panel. You will need also a new Kickstarter, but actually the image processing lib and the camera library can stay the same. So basically we would have here another camera GUI library and another ECMI-CAM AXI. But imagine if you want to change the camera sensor. So basically everything has to be changed here, or actually has to be duplicated, kind of. We still have this problem that the business critical logic and the non-critical components are still mixed together. You can see here our image processing library is still not independent. It depends on a specific camera sensor library, and then this dependency exists on the library level, and then exists also on the class level. Testing is still quite hard without UI, because if you want to make a test application, then you will have to change the main application. So basically, if you want to test it, then probably you could create a testing application that is directly talking to the image processing library, skipping the UI, and then it still has to run on the hardware, because it is directly using that camera sensor. And the same applies to the integration. Basically, this code can only run when the camera is around. Probably it has to run on a embedded hardware. If I want to take again the analogy to some building, probably this is what comes to my mind. So we have components here. It is not such a monolithic block like it was this rock house, but there are now some components. So you can see that there are windows, there is a door, and there are walls, there is a roof, but still actually everything is so closely nailed together and fitted together that it is really hard to change something without changing the other. So just imagine if you want to fit here another window or another door, then you will have to touch the walls or the pillars of this building, and otherwise it will not fit. So you have to uh, really fit the components together that they work at all. Now, after knowing the cons, let's see that what could be the intuition that could help us to take a step further. If we would make it somehow that there would be a little bit of a gap between the components, so they would not directly depend on each other, but we would have a little bit of gap between them, then we would have an easier way to work with them. And then this gap, we can say that it is like a standard. So this standard you can express as a as an abstraction, as an interface, and then the two sides they fulfill this contract between each other. They fulfill the interface, and then they become much easier exchangeable. We have also missed one concept. Quite often in the beginner object-oriented textbooks, you see that classes are the nouns, and then the verbs are the methods or the functions. And then as a very first approach, maybe this can be usable, but there are such aspects of an application that is not really coming directly from the requirement, so you can't just identify from the nouns and verbs, but there are some things that are not specified, and then the composition root. We will see quite soon what the composition root is. And then the keyword what we are looking here is the dependency injection, and then in the next level we will see how we can use dependency injection as a concept to improve our design. See you in the next video.